All right, well, I guess we'll get started. Good afternoon, everybody. My name is Kingsley Wood. I'm with the business development team based in Singapore. I've been out there for 2.5 years, and I'm going to be talking to you today about how to make scalable mobile and web apps by applying all the products and features that you've been hearing about for the last 2 days. I'm going to assume that most of you are fairly familiar with most of the AWS products at least at a high level. So this isn't going to be a 101. It's hopefully a little bit more of a 201. I'm going to try and impart some of the wisdom and best practices that we've picked up in talking to a lot of customers that are building successful web apps, scalable mobile apps that have been running on AWS for quite some time. So these are the 4 key categories I'm going to cover today. We're just going to talk a little bit about how to apply the products in ways that you can be sure that you can handle the inundation of huge amounts of traffic if you were to get successful. So that's kind of the objective here. And then about halfway through, I'm going to invite Aritra over, who's a member of the Textweb team. It's part of the Intuit company, and he's got a very interesting story to tell about how they've applied Amazon Web Services in their company to build a very scalable example of a mobile app. So let's get started straight away. The main objective, what we want to help you do, is to avoid this message coming up. That's the number one thing we don't want you to see, and your customers don't want to see. Given that today's opportunity to go global almost instantly, you've heard about all of our edge locations and so on, the ability for you to target the entire world literally within an hour is there, so you want to be ready for it. So we just want to help you just to eliminate that 503 message, make sure that you've got as much reliability and scalability in preparation for your big success, which is inevitably going to come, right? So let's focus on the first topic then, which is content delivery. One of the keys here that we're trying to address is to avoid you having to deal with all of these typical headaches. We've spoken to a lot of customers that are building mobile apps, and when they're starting to scale up, when they're just coming up with the idea, they're often encountering a lot of these kind of headaches. You'll recognize a lot of these problems. When they start to do things on a bigger scale, they start to realize just how difficult it is to deal with this. And you've been hearing that message repeated many times in the last 2 days. How can we take that undifferentiated heavy lifting? How can we do the hard work for you? So how can we alleviate you of that headache and hopefully to avoid that kind of meltdown scenario, which is inevitable when you just can't handle all that traffic yourself, right? So inevitably, you're going to get to the point where at some point, the scale becomes more than your infrastructure can handle. So if you're prepared for that, and that spike comes, and you're implementing a lot of these best practices, we hope that you will seamlessly be able to move from 10 users to 50 users to 50,000 users and so on uptime. So effectively, we want you to, first thing to think about is just offload everything to Cloudfront that you can. Now what I mean by offload, if you've got any static file, a CSS file, a JSON file, even HTML files that don't change anytime, right? Offload all of that to Cloudfront from day one. By doing that, you're taking advantage of our very distributed edge location network. We have over 35 edge locations worldwide now. And that immediately allows us to do the heavy lifting in terms of detection of latency-specific routing for you. That's a pretty big term, but basically it just means wherever your user is, we will detect where they are and direct their traffic to the very best edge location for you. You don't even have to think about it. It's simply a matter of offloading the content into S3, pointing Cloudfront at it, and letting us take care of the rest. There's a lot of subtleties that are involved in this that you don't have to work with. We're the experts at that. We spend a lot of time fine-tuning that network. So whether a user is in Hawaii or Paris or Sydney or whatever it is, we will make sure that that person gets the content delivered to them as fast and efficiently as possible from the edge location. So in terms of the actual practice here, what we're talking about is taking your content off of your servers and move it into a bucket in S3. As soon as you do that, one thing that happens immediately is you're offloading all the work that those web servers have to do in terms of delivering that content. So effectively, you're letting Cloudfront deliver the content on a repeated basis without your web servers having to do that traffic for you. The obvious impact of this is that the edge location will give the delivery of the experience much better for the customer. But a subtlety that a lot of people don't pick up is that you can now reduce the number of EC2 servers dramatically. If you think how hard those servers have to work when they're delivering content, and now you're offloading a lot of that traffic from them, you need less servers. What's that translate to? Less cost. So So we can immediately give you back some money every month just by reducing A, the number of servers, and B, the size of the servers. Scale back in, scale back down, right? Handle the same amount of traffic, and remarkably, for less price, you're actually delivering the experience better for the customer. There's some added nuances here that you can derive from doing this. One of the things is that you'll be pulling your content to a single storage location. And by putting that in one location, if you ever have to update any of that content, you don't have to go back out and fish out where that content is on each one of your EC2 servers. Because it's in one location, you're changing it once. There's a coder's paradigm a lot of you might have heard of called dry. Don't repeat yourself, right? Leave the content in one place, only one place, and refer to it always from that one place. So your durability of your static content goes up, your reliability of the system goes up, your experience goes up, and your costs go down, all by just simply implementing Cloudfront. A great example of this is a company in Singapore, and they've got this iPhone app called Perks, and it's a loyalty program. You go to a little restaurant, and they've got a deal on, and you scan the QR code, and you get a, buy 5 sandwiches, get 1 free, whatever it is, right? And it's obviously location-based, which is really cool. It means that when you're walking around, it's going to tell you which restaurants are close by or which venues are offering the deals at the moment. Now, one of the things they experienced when they first started was that all the little icons there for the restaurants are changing all the time as they sign them up onto the program, onto this loyalty program. But all of those are simply going to be content calls that can be handled by the edge location. So by doing that, they immediately improved the user experience. Every single one of the users that opened up the iPhone app suddenly thought, wow, this is remarkably fast, right? Because it gets your location, makes the query, and comes back with that content. Again, they only have to change those icons or those graphics in one place once, and then it takes care of it all the time for all the rest of the customers. Now, that's on the static content side. But about 6 months ago, we stepped up our game with Cloudfront. We added dynamic content delivery. So from the edge location, you can also include specific queries that are made back to your web server and cache them at the edge location. Let me translate that in terms of this app. If you were walking down the street and you saw a Subway, what's the special in Subway today? That's a query that goes to the web server, to the database, queries what's the special in this particular Subway, and then returns that to the user. But if you've got thousands of customers walking around the same area, they're all going to make exactly the same query. So the logic then is, why do I want my web server to work really hard at doing the same query 1,000 times when it's exactly the same result? So that becomes these dynamic calls that Cloudfront can then cache. If you think about the edge location having a persistent connection back to the source of origin, the web servers, if that query is made once and isn't going to change in, let's say, one day, you're not going to update your special on Subway that often, then that same query can be fed to those 1,000 people from exactly the same edge location without even having to hit the web server. And when I'm talking about 1,000 to 1 difference in queries, the size, again, of your servers, and the number of EC2 servers you need to handle that dramatically reduced. Huge cost saving. So in terms of the delivery, the best practice that I'm trying to impart here is deliver your entire site via Cloudfront. This means all your HTTP calls, all of the static content and the dynamic content. So you're actually, the arrow at the bottom there, you're going to direct that through the edge location. So as your users scale, you take more and more advantage of this. It's just a really smart best practice to reduce the costs and take advantage of the dynamic content delivery part of Cloudfront. So look into that. Just as an added technical note, you can split up the calls that are made depending on the type of call. So if it's a JPEG, it goes to an S3 bucket. If it's a PHP file, it's going to go to another type of region or another kind of EC2 server that might be serving up that content. So you can specify a division of the actual kinds of queries that are made all through Cloudfront. Now, if you've gone through that process and you've offloaded as much as you can on the content delivery side, you're still going to have to eventually hit the web server sometimes. So that's where we get to the managing the traffic side. You want to reduce as much as possible the number of servers, but once you've done that, you still want to do your server scaling as efficiently as possible. And this is why we recommend you load balance from the very beginning. Even if you've got one server, throw a load balancer in front of it. Now with ELB, the magic is that as you move to change behind the scenes, as you increase the number of servers, or if you change the versions on those servers, your static endpoint, your ELB DNS name, CNAME, remains exactly the same. So getting back to my original slide, the 503 is not going to happen because the customer will never have to experience an uninterrupted flow of the traffic. There is no interruption in terms of the delivery of the service. I think a lot of people used to see websites 5 years ago where it would say, service unavailable, maintenance for the next 2 hours, right? That's total old school, right? We don't want to do that anymore. We want to have the service delivering constantly all the time, no matter what's going on in the background. You saw some great examples of this with Dr. Vogels this morning, where he showed how you can take an entire fleet of servers and switch them behind the ELB. So if you take the practice of moving with an ELB from the very beginning, you take advantage of that. If you still choose to work with multiple versions, your ability to change those versions over time, systematically moving some servers to one version, back and forth, roll back, and then eventually all to version 2, you can do all that behind the scenes, behind the ELB, without any interruption to the customer. In terms of mobile apps, this has a specific advantage. The client app that you've distributed, whether it's on iPhone or Android or whatever it is, there's no need to change that once you've sent it out, because that CNAME is embedded in the actual app itself. So there's no need for it to be re-educated on which endpoint it's going to hit to see your server. Now, once you start to get a lot more scale and you start to add huge amounts of servers, the next thing you're going to have to do is, how am I going to handle the adding and removing? And that's a very important part. You want to be able to scale up and down. So as soon as your usability, you want that consistent. You want the customer experience to go the same, no matter how many users there are. So when you scale from 50 to 50,000 users, you're going to add fleets of EC2, again, behind the ELB. And that's really where auto-scaling comes in. So we highly recommend that you take advantage of the ability to both add capacity and remove capacity when you stop needing it. One of the best ways to do this is to use CloudWatch. It's that little icon there. By using CloudWatch, you can measure the CPU utilization, network traffic in and out. You can detect exactly how hard those EC2 machines are working. Now, depending on the use case or depending on the application you're running, the granularity has a very big role to play here. It might be that your application makes more sense with a few large instances, or it might make sense to have a lot of small instances. But the ability to add and remove those instances can be controlled simply by listening carefully to what the metrics are saying. You can get standard metrics like CPU and network, like I mentioned, or you can actually get custom metrics. You can export a metric from within your application. Some of our customers are detecting specific details about their application, how many threads they're running, how many concurrent connections, how many users of the day there are at the subway that's getting the special offer, and so on. They can get those as custom metrics, and then based on a threshold, they can decide whether to add or remove more capacity. Of course, this all ties into our drumbeat of making sure that you've distributed your application amongst availability zones. So make sure that you distribute multiple availability zones, 2 if you've got, more if you need, but you can actually have the region is covered by one ELB. Don't think of the ELB as a single machine or a single item in one AZ. It's a region-wide service, so it's able to distribute the traffic amongst multiple AZs. But all of this starts from the very beginning. When you have one machine, just put an ELB in it from the very beginning, and you won't regret it, because you can follow through with some uninterrupted services for your customers. Now, we've got some great examples of this. This company called Book in Singapore. It's not a misspelling. That's how they wanted to call their company. They have done some work for Singapore Press Holdings. Singapore Press Holdings is the biggest media distributor in the area. All the newspapers, online Financial Times, all the TV little clips and so on. And they distributed their app to millions, literally millions of users on iPhones, iPads, Androids, and so on. Now, as a news organization, one of the exciting things they do is they have breaking news alerts. And I'm sure a lot of you are subscribed to a similar service. They came up with a really novel way of handling this. What they do is they real-time react to this news alert. And this is how they do it. We were actually in their office one time having a meeting, and one of these events happened. So Singapore Press Holdings, the actual originator of the content, tells the system that it's got a breaking news item that's come out. So they signal back to the EC2 servers. The EC2 servers then say, okay, before we go and tell all our customers that are subscribed, let's ramp up and be ready for this. So they issue a command, and it's actually in the office. It's funny, they've got a red light and a big alarm, and it goes, this alarm's going off. And what they're basically giving themselves is 5 minutes of lead time, 6 minutes of lead time. They send a signal to the autoscaler to actually ramp up the number of machines very, very quickly. Once those machines are spun up, then they send the subscription alert to all the customers. Once that goes out to the customers, what do you think the first thing people do when they get an alert? They go visit the website. So the traffic just throws back huge amounts of volume, but they're ready for it because they've given themselves that 5 minutes. What's interesting about these guys, they're super frugal. They really know how to use AWS well. They're able to detect when the drop-off comes in the traffic, because people don't just watch the headline. They then swim around, go look at a few other items, check on their stocks, etc. Once that traffic goes below a certain level, they can then cut the machines off. And 9 times out of 10, they tell us that this all happens within 1 hour. So after about 45 minutes, 50 minutes, the traffic's down, they shut down the machines, and they've literally paid for that excess capacity for no more than 1 hour. And with AWS, if they can shut those machines off before the 1 hour time, there's no charge for the second hour. Very, very smart. So they ramp up tremendously, 5 or 6 times a week when there's a news alert, and the rest of the time really running very frugal. So it's a really smart, real-time way. You can come up with some creative ways to use the autoscaling like that. Another example, I don't know how many of you, just a matter of interest, show of hands, who's actually downloaded the guidebook? Yeah? Wow, that's cool. Very, very cool. Did you guys see the second page on it? If you go onto Guidebook and you go to the second page, it actually shows the architecture that they're using. So when Guidebook moved their entire infrastructure onto AWS, they took advantage of a lot of these services. One of the interesting parts of this infrastructure is their asynchronous processor down at the bottom there. Part of their service, and these guys are experts at guidebooks. They don't just do, obviously, AWS Invent. They've done a lot of other services, really good job of that. But what they've done is they have tasks that they can run, for instance, processing your entire agenda and then emailing it to you. Now, instead of loading up on their EC2 servers in the middle there, the main EC2 servers, they send that task to a queue service. The queue service says, OK, I'll deal with it when I can. It processes it. Sometimes it can take 45, 50 seconds to actually do the processing. It might take advantage of our email service, that's SES, to take the delivery of the email service. So they've offloaded as much of the work from the main EC2 servers to make their whole system more efficient. Very clever use of that. One more example I'll give you. This is a snapshot of the usage of one subsection of Pinterest a year ago. Now, you heard Ryan talk this morning, some fantastic numbers that they're dealing with, but what was really interesting a year ago was that they knew that their peak was about 13 instances on a daily basis. They have a fairly regular pattern at that time. But what they were able to do is recognize that let's just do the most basic part of autoscaling. We're going to divide the day into 2, and we're simply going to run full blast during the day and half blast at night. And they were able to reduce dramatically the savings just by doing that one simple fine-tuning. Now, they've gone a lot further over the process of the last year, and you heard a lot of the details of what he's done. And some of the graphs Dr. Vogel showed with the capacity following exactly. But this is such a no-brainer. It's so easy just to implement a simple switch off half your capacity at night. And they were able to reduce the cost per hour from $52 per hour during the day down to $15 per hour at night. Dramatic savings. When you're running this over months and months, you can imagine how efficient that can be. All right, every system needs a database. And now we're going to talk a little bit about the third section, which is handling the data correctly. Now, we have a bunch of database services, and you've been seeing a lot of them talked about, even the latest one launched yesterday, Redshift and so on. So there's a lot of options out there. The smart thing to do here is really to take advantage of which database fits which use case best. So starting with the basic SQL, a lot of people are familiar with MySQL. Using RDS, it makes sense right from the start off to use a master and standby configuration, which distributes your application to multi-AZ. You've heard that drumbeat quite a bit this week. But again, there's some nuances to actually taking advantage of some of the additional features we have. One of them is read replicas. If you can add a number of read replicas, you can actually offload tasks like reporting. Let's say you've got a big report that has to run once a day or once a week. By having a read replica handle that, you actually reduce the size required for your entire RDS fleet. You can use smaller machines for your master, your standby, and your read replica because the master is not being loaded up with the peak of having to do that workload of that report at the same time. Then you can also offload certain other tasks or use cases to things like Elasticache and DynamoDB, our new NoSQL database. So some of the examples of that is, as your scaling happens, as you're changing back and forth, let's see if I can go back and forth. Should be able to animate it. There you go. You can animate your scaling of your actual main EC2 instances. You can take advantage of those read replicas by making those web servers smart. And what I mean is, they've got to be able to know that if the read replica is there, it can take advantage of it. It can offload the read traffic from the master and leave the master just for writes. And you'll see some examples of that later as well from Erythra. An additional offloading that you can do is using Elasticache. We've had some customers tell us that as many as 90% of their calls to the database can in fact be moved to Elasticache. What that immediately translates to is you can scale down the size of your master RDS database. There's no need to have a huge system running when you only need 10% of the calls. And CloudWatch is actually enabled to detect the CPU work that RDS instance is doing. So take advantage of that data to tell yourself just how efficient those machines are. If your RDS database has a peak of 20%, then clearly you need to resize. So you can revisit your architecture, change the shape and size of that RDS distribution and save yourself significant costs there, while still adding more scalability as well. In terms of DynamoDB, I'm sure a lot of you writing mobile apps that have a lot of chatter between the web servers and the database will recognize some of these calls, index lookups and network traversals and so on. If you're doing a lot of calls for each request that comes from a client, so there's 10 or 15 calls, it makes no sense to be loading up a big RDS database. If you can offload that to DynamoDB, which has incredibly low latencies, less than 10 milliseconds latency to get those calls, you can make a bunch of those calls very quickly and offload that traffic from RDS as well. So all of these things are just all about splitting up your application into subsections and offloading them into the smallest possible parts to make it efficient. All right, the final section I'm going to harp on about here is this constant encouragement we give to experiment. It's amazing what you can do when you've got the ability to literally copy and paste an entire infrastructure. I like to visualize it as walking into a data center, boxing it, saying copy, paste, and playing with both of them, or 3 or 4 of them. So with CloudFormation, that's literally what you can do. We encourage you to use CloudFormation to describe a stack that can be repeatedly spun up. So nothing is manual. This is another big message. If you can automate a lot of your process in terms of spinning up the whole stack, you can spin up a stack very, very quickly, and just as quickly you can tear it down. So think about it in terms of a new developer that shows up in your company. You can give them a complete copy of your entire infrastructure to play with for a few days, let them break everything, and just throw it away. Very, very simple, very, very cheap. And that's a great way of doing this. There's a buzz term that goes around a lot now, A/B testing. And this is really the ability to try variants of your application or variants of your mobile app to see the effect on it with your customers. One of the industries that's taking a lot of advantage of this is the gaming industry. One of our customers, Wooga, had this game, Monster World. And they were very interested in the pay-for marketplace for magic wands, believe it or not. So they wanted to test a whole bunch of different pricing structures. How many gold coins would the market pay for a bunch of magic wands? And if you think this is funny, this is serious business when you're charging a few cents per gold coin or whatever, right? So what they were able to do is set up variants of the game with different pricing structures and test it with their customers. So they set up an A/B situation where one group of customers, again, everything behind the load balancer, notice that. So one group of the customers will get one pricing structure, the other customer will get another pricing structure. And after a few days or weeks, they could detect which one is more efficient, which one was generating more gold coins for Wooga, and they just throw away the other one and duplicate the one that works. Very efficient use of that. All right, so now I'm going to hand over to Erythra from TextWeb, and he can tell you about how he's applied all these services. There you go. Thanks.
Yeah, hi guys. My name is Erythra, and I'm a software engineer on the Textweb team. So Textweb is an experiment which is run by Intuit. So I'll be talking about the different kind of experiments and architecture journey that we've had taken on AWS, and just give you an insight as to what best practices and guidelines we have followed while architecting our application platform over AWS. So to give you an introduction to TextWeb, so TextWeb is a global, bite-sized information and content platform which allows fast and seamless consumption of information over mobile devices of any kind. So just to summarize it, if you have a web application and you want to SMS enable it, so TextWeb is the platform to go. You can just go there, build your app, and it's available to the billions of mobile users. And we all know that every mobile phone, be it of any platform, iPhone or Android, is always capable of sending a text message. So your app is instantly available to the billions of users across the world. So right now we are active in India, and our base is mostly there. And we're also active in US and Canada. So just to talk about some numbers, we've got some 1 million monthly active users, and we've got a total of 5 million users. And we have like 10,000 apps on our platform, and we handle like 150 million monthly transactions. So enough of talking. I mean, you can just try it out. You can just take your phones out and just send @wiki space internet to our shortcode in the US, which is 898932, and just get a feel of yourself. I mean, just get a feel for yourself about how the platform interacts. So I'm just going to jump into the journey of how we started off building this whole platform. So it was all in 2011, when we wanted to scale up the whole platform. It was just a team of 2 members, 2 engineers, who wanted to just scale up the whole platform for an event that was coming up in March and April. And we had the concepts and everything ready. We definitely had the code. But the biggest problem that was haunting us that time was infrastructure. And this was something that, as a very small experiment that we want to run, we do not want to trouble the ID guys, and then just get through the hassles of, raising a ticket for every system you will launch, and then just deploying applications overnight, and then just worry about all the auto-scaling and all the other things. So we wanted to get onto the public cloud during that time, and then we kind of, that was the biggest problem on our head. So we went to the drawing board, and we kind of discussed among ourselves as to what are the things that we wanted to have from the solution that we were looking for. So one thing in our mind was very clear. We wanted to seamlessly scale because we were already aware that the amount of loads that we would get, because since we were on mobile devices, that could send us a text message, and each text message could hit our platform. So we were always aware that we would basically require auto-scaling no matter wherever we go. So that was definitely the priority number 1 for us. Second was, we definitely did not want to invest a lot because it was a small team, and then we had limited budget, and we want to just run a small, quick, lean experiments and get the results as quickly as possible. And also, as Kingsley mentioned in his talks, we want to experiment a lot since it's a mobile app, and the nature of how the users interact, and we want to test it out quickly with different forms of architecture and what is the best configuration for our system. We just quickly wanted to test it out on the infrastructure we're going to choose. And the last but not the least, we wanted to focus on building the product rather than maintaining all the ID stuff that goes around, right? So it was just a 2-member team, as I just mentioned. So we did not have the time and the effort to just spend and just look at the logs and then just figure out which network cable broke or things like that, right? So these were the 4 important things we're looking out for. And then we evaluated a lot of vendors in the market. But then the real answer we found was with Amazon Web Services. It was fairly new to us during those days. And we found all these factors to be present in Amazon Web Services during those days. And then these are the 4 major advantages that we found with AWS, which was one of them was definitely it allows us to quickly and we do rapid deployments with AWS. We definitely had issues with our own vendors that we dealt with in the past. It allowed us to also do rapid prototyping and testing with all the different forms of architecture that we wanted to play with. We definitely had no upfront cost with it, and it also allowed us to get to our results very fast and in quickest time possible, right? So I'm just going to talk about the different architecture. What is generally the whole architecture of TextWeb. So when you send a text message, it goes to your cellular operator, and then from there it travels to the SMS aggregator or the SMS gateway, and from there it goes to our platform, which is hosted on AWS. And as I said, it's an application platform, so it makes a third-party call to applications which are hosted either in AWS or it could also be on the public internet. And this whole process is asynchronous. So your request comes to the cellular operator, and from there to our platform. It doesn't necessarily mean that the response will be received on the same request line. So as soon as the response is available, we just send it back to the end user on a different line, right? So our early days with AWS started off by doing a lot of performance in A/B architecture or A/B tests. So initially, we started off with a lot of EC2 servers and a very small database. So what we thought is that horizontal scaling would give us the breadth to run at massive scale. As I just mentioned that since we were available on text, anyone at any point in time could basically hit our platform, and then we would get a massive amount of requests no matter what. So we thought horizontal scaling is the way to go, but then we missed out a very important point that ultimately the single point of failure in an application will always be a data layer, and then if you don't secure a data layer, you're going to be doomed. So this configuration did not scale well, as obvious. So we tried with a different configuration, and this was, we tried to reduce on the number of EC2 servers, thereby reducing cost, and also scaling up on the database side, which allowed us to, scale really well to whatever amount of load we got. So this was about the initial architecture A/B tests, which AWS allowed us to do, since it was very flexible and could be done like with a 2-member team as well. We did not have to hire like 100 engineers to, just to make all these changes possible. And then, as I was mentioning, so we had a Cricket World Cup coming in March and April, and cricket, as you know, is a very important sporting event in India. It's followed by billions of people. And the World Cup, it happened in India itself, so we kind of expected a lot of traffic to come. And as obvious, the request count was like amazing. So it just went up from 10,000 requests in a day to about 1 million requests in a day. So, and we did not have to do any changes in our code or our systems to make that possible. Since we had already done the configuration A/B tests before, it allowed us to just scale up from 2 servers to 12 servers in just a matter of days. So auto-scaling definitely helped us, and it allowed us to perform really well during the World Cup days. And then, as we had already seen in a lot of slides from the morning, that how auto-scaling and elastic needs have to be managed. How auto-scaling helps us in maintaining elastic loads. This is our chapter of the story. So it shows 2 peaks in a day. It's a typical day in March 2011 when the cricket match is in progress. So the 2 peaks that you see is that Team 1 is playing, and the second peak is when the Team 2 is playing. So, and the orange line shows the amount of EC2 servers that we require to handle that kind of traffic. And as you see, the number of EC2 servers follow very closely with the traffic patterns that you have in blue. So during the daytime, when the match starts, auto-scaling kicks in, and then it just handles the load for us. And then as and when the match gets more exciting, again, we scale up. And then when the match ends, like a magic, all the servers cool down, and then we don't have to worry about running or over-provisioning our systems and spend more on AWS, right? So it just seamlessly, helps us in maintaining the traffic and providing our services to, millions of users. So without auto-scaling, what we would have ended up doing is we would have ended up running 192 server hours, and now we run just 100 server hours, which means we are saving on 48% of our costs. So that's a huge amount of saving, given the fact that we were just running an experiment, and we wanted to, just get the results out upfront, and then without, having to spend a lot on it. So in detail, our architecture is something like this. So as you, if you had tried sending a message to our platform, the SMS would have traveled to the cellular service, and then to the SMS aggregators, who basically collect all the SMSs and then send it back to us. So our DNS system is backed by AWS, so we use Route 53. And then it goes to the load balancer and then just sends a request to our servers which are hosted in multi-AZ. And then from there, we basically make a call to the developer app that may be hosted in AWS, or it could be in public internet. We also do some kind of logging, and then we make use of DynamoDB, we make use of Elasticache and RDS. For different reasons, because some of our transactional data goes to DynamoDB, and some other data goes to MySQL, and we also do heavy lifting from Elasticache. Then we also have a job which runs daily to collect the data from our data layer to our corporate data center, where we do our batch processing and then big queries on top of the data that we collect. And most interesting part of the architecture is that we made heavy use of CloudWatch alarms to trigger auto-scaling. There's something that I want to highlight here is that the default auto-scaling metrics that Elastic Beanstalk provides doesn't suit all applications. So in our case, what we figured out is that all our EC2 servers were half used, and then the CPU on each of them was not being consumed so heavily. So the default metric provides the CPU scaling. So we thought, how about setting up CloudWatch alarms to trigger auto-scaling themselves, right? So these CloudWatch alarms basically look for the amount of threads that are there running on each of the EC2 servers, And then as and when it breaches a certain threshold, it basically triggers auto-scaling automatically, and then one of the EC2 servers is added, or it is reduced depending on the conditions, right? So that's how we have taken care of auto-scaling in our case. And some of the architectural changes that we have done over the period of 1.5 years since 2011 is that we definitely had to handle a lot of database workloads. As and where our user base also grew, and then a number of apps on the platform also grew. So to maintain that load, we have basically introduced Elastic Cache in May 2011, wherein which is basically a write-through cache for us. So we write to the database, and then we read everything back from the cache. So the database currently just handles one job, which is just to get all the data and then just store it. Basically, all the reads are done from Elastic Cache, and all the workload from the database has been reduced by 90% of the times. Then the write-heavy needs of our application were solved by bisecting our application into transactional as well as business data. So transactional data goes only to DynamoDB because we wanted to take advantage of the write-heavy needs and the high I/O-intensive nature of DynamoDB. So we basically pushed all our transactional data to DynamoDB, and then had a EMR job running, which basically takes the data out of DynamoDB and moves it into our data center. And then, as I mentioned in my architecture diagram, we have auto-scaling metrics set up, which is basically leveraged through CloudWatch alarms, and then which monitor the health of all the EC2 servers that we have running. And then it basically figures out how many threads are running in each of the EC2 servers, and then just auto-scales them depending on the conditions that are breached, or if they are not met. That's pretty much what I have to share about the journey that we had with AWS. And I'll be sharing it back to Kingsley, and then if you have any questions, then I'll be happy to take it. Yeah.
Great. Thanks very much, Aricha. That's a great story. Yeah. Thanks very much.